Welcome everyone. Um, this question came in JEE Advanced 2023. We are going to do question number 5. Um, a monochromatic light wave is incident normally on a glass slab of thickness T. So the glass slab is such that the refractive index of the glass slab it changes from bottom to top in an increasing way. So its refractive index is increasing, and because of this, optical path length of light will vary. So that means that light will travel quickly uh, in the medium which is optically denser. So it will travel quickly through N1, and it will come out of the light slab or the glass slab faster. And then when it is traveling at the point N2, then it would be traveling in a much slower manner. So that means that when the light has entered at N2 uh, and it has left N2, the light at N1 will have to traverse the whole distance D and cover some extra distance. Figuratively, we are trying to say that light will travel this particular distance in N1 and the same distance in N2 as well. But since light is traveling slower here, N1 will has time to travel more distance, which causes a deflection of the light path. Let's say this distance through which light has to travel extra is some x. This particular distance is h, and the angle with which the light has to deflect is some theta. So this is how the wavefront is going to be. The points E and F on the wavefront would be vibrating in the same phase as A and B. So phase difference between E and A would be same as the phase difference between F and B. So this distance is x. Again, marking this distance as x. Uh, what is the optical path AE? If I were to say, what would this distance be? So this distance AE is simply the refractive index N2 into the distance d with which it has traveled. Similarly, we'll say what is the distance traveled in this case? What is the geometric path which it has traveled? So geometrically speaking, it has traveled through BF distance. If I want to say what would be the BF distance, so it would be again N1 d plus this distance x. So we multiply the geometric distance with refractive index to get the optical path. So these two distances have to be equal. That is N1 d plus x should be equal to N2 d, or x has to be equal to N2 minus N1 into d. So this implies tan theta is equal to N2 minus N1 d divided by h. So this is option number B and option D. The deflection of the angle depends only on the difference of the refractive index between the points A and B. So that is this one. So basically I want to reiterate what is optical path length. Optical path length is that distance which we use to calculate the phase difference between two different light paths. So the optical path length which we have when it is traveling to N2 is N2 times D, the geometric path length. In the same way, optical path length when it is traveled through BF is N1 into D, that is the geometric path length D into the refractive index N1 plus the x distance extra it is traveling uh, in air. So then we say that these two distances have to be equal. Optical path length have to be equal for the phase difference to become zero between AE ray and BF ray. So we equated that to get x. Now x is the geometric length. That geometric length we can calculate to find what is the deflection. So thank you for joining. Have a good day.